Assalamualaikum warahmatullahi wabarakatuh. So, we from Group 4, from EC1101L, the topic that we choose for this video presentation is Application of Integration. So, my name is Nur Sabrina Yusni binti Husaini with metric number 2020809376.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Anshad bin Muhammad Ali. My metric number is 2020620252. So today I want to talk about a washing method.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Fatihi bin Uthman. Today I will be discussing about problem statement regarding application of integration. Without further ado, let's go.
One of the very useful application of integration is finding the area and volume of the curve figures that we couldn't typically get without using calculus, since we already know that can use the integral to get the area between the x-axis and y-axis and a function. We can also get the volume of this figure by rotating the figure around either one of the axes. We can learn about this application of integration in the topic below. First is area between two curves. Second is volume solid of revolution, which is have three method, which is this method, washer method, and shell method.
Figure below show that regions are bounded by the curve y equal to x squared, the line y equal to 2x plus 4, and the y-axis. Insert 2x plus 4x minus x power of 3 into the formula and integrate them. After that, substitute x with 2 and we get the answer 8. Next, I want to show to you guys how we use application of integration to find volume with this method. First, the region are bounded by y equal to x power of 2 plus 4 and y equal to 2. In the interval 1 and 4 is revolved about the line y equal to 2. Find the volume of the solid of revolution. First, insert the x power of 2 plus 4 minus 2 into the formula. After that, integrate them. Substitute x with 4 and 1 and we get the answer.
So for our next topic in chapter application of integration is a washing method. So a washing method is like a this. So this one is this and a hole. This one is hole. So like a this and a hole. The formula for the volume of washer requires both inner and outer radius, which is we know it as R1 and R2. Now suppose the generating region R is bounded by two functions. Is y equal to fx on the top and y equal to gx on the bottom. So based on this formula. So this time when you revolve R around the axis, the slice perpendicular to the axis look like washer. So this is an example. So this one is for the question. So this one is the inner. So the inner function or inner. So this one is R2 and this one is R1. So just by using this formula, and you will get this. So the square here, why we need to square is because we need to uh, find the volume. So it will become like this, and a hole at this. As you can see, like this one image, and this is the hole. So it look like a donut or a washer. That's why we call it a washer method. So this is a formula. During do this formula, you must be careful because do not careless during the expand. You need to expand this one. You need to expand this square for solution. You must be careful because if you careless, it might be wrong for you to get the right answer. And read the question carefully and watch the revolving axis. It can be x axis or y axis. So for the problem solving, so this is the question. Figure out by using washer method. By using a washer method, find the volume of solid generator R. This one is rotate x axis. So this R going to rotate at this axis, x axis. So it will rotate. So this is the axis, the revolving, or so this region are bounded, gonna rotate here and be like here. So this is the result. So firstly, by using the formula, you just need to identify which is the the outer radius and the inner radius. So just and when you black, so and then just expand them like this, your square, and then you expand them carefully to not make any mistake here. And then after you expand them, you need to integrate them. Yes, integrate and become this. After integrate, then and then put into here, then we get the unit here. So it's kind of easy actually, but you must read the question carefully because the question can ask the y axis or y axis. If the question asks on the y axis, so it will become like this. So it will come like this. This is the y-axis. So we are gonna rotate like this. Uh, so, hmm. So, most of you must be wondering why we as engineer uh, studying this method. What is use? So this is actually the use for us to make a building. So just so this is example. So this one is y. This one is x. So we just put an equation here and or another equation here. So and somehow we just do a washing method so we get the the building that we want to build, such as like this one. So you can see there a hole here, so it look like a donut. And thank you for watching.
The last method for volume is the shell method. The shell method for finding volume of a solid of revolution uses integration along an axis perpendicular to the axis of revolution instead of parallel. As we seen with the disk and washer methods, the nice thing about the shell method is that you can integrate around the y-axis and not have to take the inverse of function. Also, the rotational solid can have a hole in it or not, so it's a little more robust. It's not intuitive thought since it deals with an infinite number of surface area of rectangles in the shape of cylinder shells. Instead of slicing the solid perpendicular to the axis of rotation creating cross-section, we now slice it parallel to the axis of rotation creating shells. Problem statement question C. By using the shell method, find the volume of the solid generated when the region R is rotated about the y-axis. So the solution for question C, we must remember that cross-section is parallel to the line of revolution. When the vertical line of revolution, we must using values of x. Since the region is on the right hand side of the line of revolution, we can assume that the shaded region is x. So the right hand side is x, Rx is right minus left. So the right is x, which is the shaded region, minus 0, which is the y-axis. So the Cx equals to upper function minus lower function. The upper function is 2x plus 4 minus x cubic. And we got 2x plus 4 minus x cubic. So the formula of washer method volume is 2 pi integral of Rx Cx dx. So we just enter the formula using Rx and Cx and just expand the x and integrate. And 2 and 0, we just enter the the value 2 into the x, and 0 will become 0, and the answer will become 208 per 15 pi unit cubic.
And lastly, for the conclusion from the chapter that we study, chapter the application of integration. So the conclusion is from the chapter that we learn. Just a defined integral can be used to find area under a curve. So we can find the area under a curve. So and can be used to find area between a two curves. So if have a two curve here, so have two curve, so we can find the area inside of these two curve. And to find the area between the two curves by function, integrate the difference of the function, the arc length. So we can also find the length of the arc of a curve. It can be calculated using different. So what is integration and its application? Integration is a way of adding a slice. So a slice and can a slice to find a hole. That means you can, from the slice you can find a hole. Integration also can be used to find the areas, as I mentioned before, to find the areas, volume, center point, and many useful things in daily life also, or making one building. So we also using this integration and application. As example, we need to dig a hole in in a mount in a mount in a mountain. So we need to dig a hole to make a way. So we also use this method to calculate to calculate. So to calculate, as example, this one, and then with using it to dig a hole inside of the mountain. So that is the conclusion that I got so far. And thank you for watching. That's all from us, from group 4 EC1101L. If we got any wrong here, we are sorry, because during the pandemic it's hard to make a video or presentation, especially for the because we far from each other. And thank you for watching. I hope you guys get a lot of new information from this video. Bye.